This is Euclid Book 11, proposition number 2, and it says as follows. If two straight lines cut one another, they are in one plane, and every triangle is in one plane. For let two straight lines AB and CD cut one another at point E. Well, here's AB, here's CD, and they cut each other at point E. I say that AB and CD are in one plane, and every triangle is in one plane. For let points F and G, which this is F here, and this is G right there, be taken at random on EC and EB. Well, what is EC? Well, this is EC right here. What is EB? That's what that one's right there. Okay? And let CB and FG be joined. Okay, so we're going to join C and B. There's CB right there. And we're going to join FG, which is this one right here. And let FH and GK be drawn across. Okay, well, what's FH? That's that one. And what's GK? That's this one. I say first that the triangle ECB is in one plane. Well, what is ECB? Well, that's ECB. This triangle, this great big one right here, is in one plane. 4. If part of the triangle ECB, either FHC, which of course this is FHC right here, this would be part of this great big triangle right here, or GBK, well, this is G, B, and K right here, and this is also part of this great big triangle. So whether we take this part here or this part here is in the plane of reference, and the rest in another, a part also of one of the straight lines EC or EB. Well, what's EC? EC, this is that one there. What's EB? That's this one here. Will be in the plane of reference and part in another. But if the part FCBG, well, what is FCBG? Well, this is FC, okay, B and G, okay, be this from here to here to here to here. Be this little rectangular thing right there. Okay? But if the part FCBG of the triangle ECB, which is ECB, okay, so this whole area right in here, which is part of this great big triangle, but if the part FCBG of the triangle ECB be in the plane of reference and the rest in another, a part also of both the straight lines EC and EB will be in the plane of reference and part in another, which was proven absurd. Therefore, the triangle ECB is in one plane. This is in one plane. But in whatever plane the triangle ECB is, in that plane also is each of the straight lines EC and EB. So since this whole triangle is in one plane, then these two lines also have to be in one plane. And in whatever plane each of the straight lines EC, EB is in, that plane are AB and CD also. And this is by Euclid Book 11, proposition number 1. Okay? So because these two lines are in one plane, that forces these two lines to also be in one plane. Well, actually, it forces these two lines to be in one plane, so therefore it forces these two lines to be in one plane. And every triangle is in one plane. And that's the end of the proof. Alright, I want to thank you very much for tuning in. I hope you guys have a very Merry Christmas. And I will tell you more in a future video, so I want you to stay tuned.